You know, we're surrounded by technology every single day. But this explainer is all about shifting your perspective from just using it to actually building it.
I mean, think about it. We spend our days scrolling through apps like TikTok, connecting with friends, and watching all sorts of content.
Or maybe we're playing games, or using creative tools like Scratch to make our own little animations and projects, just for fun.
But have you ever really stopped and thought about what's actually happening behind the screen?
Well, if you've ever asked yourself that question, how was this stuff actually made, you are in exactly the right place. We're about to go on a little journey to transform you from a tech consumer into a tech creator.
So here's our game plan. First, we'll get you set up with your creative toolkit. Then we'll dig into understanding your materials. After that, we'll uncover the problem-solving blueprint, cover the essentials of building a safer internet, and finally get you ready to create your first masterpiece.
All right, first up, let's jump right in and grab the most exciting tools in the box. I'm talking about the stuff you can use to make incredible digital art, posters, and yeah, even your very own games, like right now.
Okay, so when it comes to creating images, you've basically got two main types to work with. On one hand, you've got vector graphics. The easiest way to think about them is that they're made of pure math. The really cool thing is you can scale them up to the size of a building and they'll stay perfectly crisp, which is why they're perfect for logos. On the other hand, you have raster graphics. These are made of tiny little squares called pixels, just like a photograph. And because of that, if you try to make them too big, they get all blurry and blocky.
And hey, building a game? It's not some kind of secret magic, I promise. It's actually a logical, step-by-step process. You start with a storyboard to plan out your big idea. Then you code it to bring it all to life. Next, you debug, which is just a fancy word for finding and fixing all the little errors. And finally, you test it to make sure it's actually fun to play. See? It's a clear path anyone can follow.
Okay, so we have some tools now, but what are we actually building with? Every great builder needs to understand their materials, so let's pop the hood and take a look at how computers really work.
At the absolute core of everything digital is a very, very simple language. It basically only has two letters, on or off, a 0 or a 1. This is called binary, and believe it or not, it's the language that powers everything from your phone to the entire internet.
So when you look at something like this, it probably just seems like a random jumble of numbers, like some kind of secret code that only a genius could possibly understand, right?
Well, it's not. It turns out this is just the computer's way of spelling out hi. It's a perfect example of how really simple building blocks, just those zeros and ones, can be combined to create complex, meaningful results.
And that simple principle applies to, well, everything. Text is just binary codes that represent letters and symbols. Images are just a grid of pixels where binary tells the computer the exact color of each one. And sound? That's recorded by taking thousands of tiny digital snapshots every second. It's all just zeros and ones, arranged in incredibly clever ways.
So this next tool is probably the most powerful one in your entire kit. And it's not a piece of software, it's a way of thinking. This is the master strategy for solving almost any complex problem, whether you're coding or not.
It's built on 4 key pillars that help you think more strategically: decomposition, pattern recognition, abstraction, and algorithm design. Let's just grab that first one, decomposition, to see how this works in the real world.
So, decomposition. Sounds fancy, but it just means breaking a big, scary problem into smaller, manageable chunks. Think about it. If your problem is make a pizza, you don't just do it all at once. You break it down. First, prepare the dough. Then add the sauce and cheese. After that, add toppings. Finally, bake it. By breaking it down, a huge project suddenly feels way less intimidating. Now, being a great creator isn't just about what you build. It's also about being a responsible one. Every builder needs a safety manual to protect themselves and their work when they're online. A really key safety skill is learning how to spot scams, like phishing emails. They're designed to trick you, but they almost always leave red flags. You want to look for things like a generic greeting, a fake sense of urgency to make you panic, a web address that looks a little sketchy, and honestly just bad spelling and grammar.
And that brings us to a crucial question you should ask yourself. Are you protecting your accounts properly? Is your password actually strong enough?
The difference between a weak password like password123 and a strong one is massive. Here's a great trick. A strong password that's still easy to remember can just be 3 random words combined. Then you just added a number, a symbol, and a capital letter. Yeah, duck hash fox 8 prison is strange, but you'll remember it, and a computer would take forever to guess it.
So, let's recap. You've got the toolkit, you understand the materials, you have the problem-solving blueprint, and you know the safety rules. You're ready. You are ready to start building.
And if you're ready to level up, there are so many cool ways to do it. You can test your skills in competitions like the Bieber's Challenge. You can build a portfolio of your work on GitHub to show it off. Or you could even start building with hardware using amazing gadgets like a Raspberry Pi.
So, we've pulled back the curtain. You've seen that technology isn't magic. It's just a set of tools and a way of thinking. You have the toolkit now. So the only question left is the most exciting one of all. What will you build first?